Hello, everybody. My name is Laurent Gautier. I'm a botanist. I work in the Botanical Garden of Geneva, Switzerland. And well, I will first start by sharing my screen and begin to try to give you a little idea of my background. I spent 3 years in Ivory Coast for my PhD on forest-savanna transition, and I had the opportunity to see also what fire and savanna, how do they interact. And then I moved to another field still in Ivory Coast and developed deforestation monitoring using remote sensing. And then since 1994 until the pre-COVID era, I was mainly active in Madagascar, making flora checklist and vegetation studies, mostly in forest, I must admit, in existing or protected areas. I also have a systematic interest in the tree family Saphotaceae, and well, on the left you can see more or less the place where I used my boots in Madagascar. Now, what I want to talk about you is a few reflections. Of course, I was raised in a kind of classical French way of perceiving vegetation and vegetation changes. And for Madagascar, this type of approach, of course, recognized the existence of natural grasslands in mountain situation, and also mixed it with the woody elements in what was called the western slopes of around the Tapia, what is now the Tapia forest of Wapaka-Bogeri. But apart from that, all the rest was considered as mainly the result of deforestation and of very little interest. And of course, I must say that during my experience, I had the opportunity to see a few things. And of course, this was this very striking image shot from the space shuttle, where you see the Betsibouk estuary with a lot of red water pluming off in the sea, and also a little bit of smoke there. And well, when you see this, you say there's something quite strange. There's something here that doesn't seem to be in a steady state. Something is going on. From my experience in Manongari in Northwest, we had the forest, we had a kind of transition zone where agriculture was existing. And in the foreground, you see places where definitely grassland had developed in soil that were not capable of restoring any forest. So I was quite, how do you say, impressed, or well, I had this in mind for the rest of my work and this is at that point that I came to recently. I was in charge of writing the introduction to Steve Goodman's book on protected area and the introduction on vegetation, and I also contributed to the edition of the flora part of his recent to be published new natural history of Madagascar. And then in this framework, I must say that I was still not considering grassland as a natural habitat or as an habitat that deserved any attention. Then there was some talks and some discussions with some of you, and well, I've really shared with you the impression that something must be done to get a better understanding of the grassland biomes in Madagascar. So to be short and try to answer the questions that were raised, how does your data or expertise contribute to an understanding of grassy biome evolution in Madagascar? Well, as a botanist, what can I contribute? We know that paleobotanical data give us evidence of species or sometimes genera or families present in the vicinity of the sampling area along a time series. What is our expertise useful? As having a kind of knowledge of Madagascar flora and of its role in present vegetation dynamics, Beyond the simple forest-grassland dichotomy, we can bring light on past processes. Specifically, for any given taxa, we have an idea of its life form or its biological type. We have an idea of its preference, habitat preference in terms of water or light or temperature. And we have also an idea of its tolerance to fire. So probably we can develop a kind of classification of or guild of species that can teach us a bit more than just is it savanna or a forest or grassland species that we're dealing with. And to illustrate this, I have here a picture of Trema orientalis in the field. And this is a species that is clearly related to forests, but what is more interesting is that it's related to a destruction of forests. It is a species, an early pioneer in forest restoration, as it has appeared on several occasions in the various pollen cores that have been extracted to Madagascar. I think there's much more than simple forest grassland dichotomy information of the presence of this species in particular. Then our knowledge of Madagascar flora is also needed for a critical point of view on the taxa identification from pollen. Is the taxon extant in Madagascar? In these lists, there are several taxons that are not existing in Madagascar now, at least. So is it a disappeared species, or is there a risk of confusion with the species that we have here? And knowing what are its relatives might help understanding if this pollen has been misidentified or not. And also probably we can help in our expertise about the groups. And we have when we have only an identification of a genus or a family, can we say something? And if yes, what can we say? Now to the next question. How can your disciplinary understanding of grassy biome distribution evolution be aided by cross-disciplinary engagement? And this, I must say that, well, when I look at the landscape and I see this, soil accumulation is a slow process that can probably help us rewind a little bit in time. You know, the lavaca, these deep scar and thick lateris, I think they really have something to tell us. Here I have a satellite image of the region of the Ambuhi-Janahari protected area, or what's left of it. And you can see that there are numerous scars of this kind. And if you go down to a close-up somewhere, you can see also that recolonization by forest is going on in these lavacas, and that the landscape, today's landscape, keeps a lot of testimonies of the past and of the process that have been ongoing and that could possibly go on elsewhere. So in this respect, you can also clearly see that deforestation here through ancient lavacas has had a tremendous impact on the landscape. And in that sense, geomorphology, the study of landscape itself and its generation, has certainly a lot to tell us about the past of the grassy biomes in the island. So what do you see as limitation to data within and outside your field with respect to inferred Holocene grassy biomes distribution? We critically lack spatial coverage in grassland vegetation studies. Some spots have been highlighted as diverse and endemics rich by some of you. The vast majority remains unexplored and believed to be species poor and uninteresting, and thus they are still unexplored. What research questions need to be answered to move an understanding of grassy biome distribution forward? Well, I think geomorphology, as I said before, geomorphology studies based on remote sensing, probably using radar, satellite imagery to get very precise altitude measurement and reconstruct the shape, could help us understand the various landscape we're facing and what they have to tell us. And of course, we need much field work. We need field work that is coupling vegetation sampling and pedological studies. And I think these are the tracks I would think are the most interesting to follow And with that, I will conclude, and I would like to thank Leanne and all the organizing team. I think it's very good that they've taken the initiative to start this dynamics, and I really look forward to what will be going on in the near future. Thank you to all also for your attention.